Last week, I showed you what a workers' compensation claim really looks like. Handwritten incident reports, ER discharge summaries, and different rules in every state. The problem is obvious. The standard AI tools were not made for this. This week, I'm going to walk you through the 3 hypotheses that drive every design decision in VenturiFlowAI. One slide at a time so you can see exactly how they connect. The industry is converging on the term agent harness to describe the infrastructure that wraps around AI models, governing how agents operate, access tools, manage state, and interact with humans. If the model is the engine, the harness is everything that makes the engine safe to drive. VenturiFlowAI is an agent harness, a specific kind, a governance-first agent harness built for regulated verticals, where the harness must enforce compliance, not just enable capability. These 3 hypotheses define what makes it different. Hypothesis 1. Autonomy must be earned, not assumed. Here is how most AI implementations work today. You deploy the AI and then human verify its results. The problem is that you have restructured the human's entire workflow around the AI in the regulated industries, creating a cultural friction before the technology has even proven its value. VenturiFlowAI does things differently. Let me explain how. Every step in a VenturiFlow workflow is one of the 3 execution types. Deterministic steps are rule-based programs. For example, calculating temporary total disability benefits is just a formula. Looking up a fee schedule is just checking a table. Figuring it out statutory deadline is date calculation. These steps always stays deterministic. There is no need to add AI where a formula already works perfectly. Second, human steps are tasks that still need a person's judgment or ability to handle messy, unstructured information. For example, deciding if an injury happened at work, pulling details from a handwritten report, or checking for possible fraud. Rules can't handle this, but people can. Third is autonomous. Steps are handled by an autonomous agent, but only after it has proven itself through a process called shadow evaluation. This is the promotion path shown at the bottom of the slide. From human to shadow to autonomous. It never goes backward, and the autonomy is never the starting point. In shadow mode, the autonomous agent operates invisibly along the human examiner, who continues their job as usual. The agent processes the same information independently, and its results are compared with a human's decision. As framework reviews hundreds or even thousands of claims, it collects data from these comparisons. It looks at the 2 things: how often agents' answer match the humans, and whether its reasoning can be explained clearly to a regulator. When the evidence is sufficient, the framework recommends promotion. A human decides whether to accept or not, and a human decides whether to demote it if performance degrades. The framework manages the evidence, human manages the trust. Hypothesis 2. Building workflows at a runtime is better than relying on a pre-built agents. Here is how automation usually works today, shown in the left column. You start with the standard operating procedure, SOP. Someone turns it into requirements, and engineers write the code, QA test it, and then it's deployed. That's for handoff. Each one can introduce mistakes. Every time the rules change, you have to repeat the whole process. VenturiFlowAI takes a much shorter path, shown in the right column. The SOP becomes an agent operating procedure. The framework injects the AOP at a runtime and composes the workflow from it, rather than compiling and deploying it beforehand. That's what runtime composition means. So the question comes, what's inside an AOP and why is it important? The AOP defines the agents and label each one as either deterministic or autonomous. This label is crucial. The deterministic agent just follows its steps and gives a repeatable result. It doesn't make any decision. An autonomous agent gathers information through its steps, then uses that information to make a judgment and gives a confidence score. Autonomy belongs to the agent as a whole, not to any single step. What about the steps themselves? Each step uses one of the three things. First, a tool. This means anything that interacts with another system, like calling an API, updating a database, running a browser automation, sending a message, or writing to another platform. Second, a managed business rule set. These are versioned, reviewable rules with no guesswork, like benefit formula or eligibility checks. Third, a knowledge source, a curated knowledge base, such as treatment guidelines or legal texts, that step can pull information from. Here is how it all fits together, and this is the part of the design I am most proud of. Imagine an autonomous agent that decides if a claim is compensable. First, it uses a tool to get a claim and employment data from another system. Next, it uses a business rule set to figure it out the waiting period. Then it pulls the relevant rules from the knowledge base. None of these steps is autonomous by itself. They just collect information. The autonomy comes when the agent looks at all the results together and makes a judgment about the claim, along with the confidence score. A deterministic agent could use the same steps, but it would just return the result without making a judgment. The AOP is where this whole setup is defined. This setup changes who is responsible for what. Compliance teams own the AOP, the business process, the order of steps, and the rules. Engineering owns the tools, which are the integrations that steps use. VenturiFlowAI manages the runtime, which means reading the AOP, connecting everything, and running the workflow. When a regulation changes, like a new benefit cap or a fee schedule, you just update AOP configuration instead of starting a new development project. Engineering only gets involved if a new capability is needed. Here is why this is important for workers' compensation. If a company operates in a 5-state, it has a 5 AOPs. The workflow structure stays the same, but each state has its own benefit formulas, fee schedules, and treatment guidelines. The framework is the same everywhere. If Florida updates its permanent partial disability formula, only the Florida AOP changes. The rule for California, New York, Texas stays the same. Rules for each state are never mixed together in the code. One framework supports 5 states with no need for a separate code branches. Hypothesis 3. Use autonomous agents for gathering evidence and making judgments, and deterministic agents for precise computation. There is a clear line in the framework. Autonomous agents deal with uncertainty while deterministic agents handle precise tasks. On the side of ambiguity, you have a task that involves evidence and judgment. For example, an employer might write a narrative about an incident. A doctor might record findings in an unstructured summary, or an employee might describe their injury in handwriting. An autonomous agent has to read things like a handwritten note about how someone got hurt, or a doctor's long paragraph with the diagnosis hidden inside. There is no simple format to follow. This is where AI reasoning is most useful, turning messy information into structured data, deciding where to send a claim, sorting out incomplete paperwork, or spotting for possible fraud. On the precision side, you have tasks that are all about exact calculations, like TTD benefit calculation, PPD payment schedules, a medical fee schedule checks, or figuring it out statutory deadlines. These use specific state formulas, so the same input always gives the same output. Using an autonomous agent here doesn't help and could even add risk. The boundary is enforced at runtime by the confidence gateway. Every autonomous agent output carries a confidence score. Above the configured threshold, the output flows automatically to the next step. Below the threshold, the workflow pauses. The human is notified with the full context. The agent's output its confidence score and the reasoning trace, and decides approve, override, or escalate. That decision is logged as a first-class workflow event. On the right side of the slide is the part that makes the boundary practical. The thresholds are not one size fits all. They are configurable at three levels. Global is a safety net. The AOP level threshold overrides the global, and an agent level threshold overrides AOP. More specific always wins. And notice where the hierarchy stops. At the agent. The confidence score belongs to the autonomous agent because the agent is what renders the judgment. An agent that extracts the routine field like employer name can run with a generous threshold. An agent that assesses compensability, the determination of whether the claim is payable at all, gets the tightest threshold available. Now, here is how all three ideas fit together. H3 explains where the autonomy boundary is, right? H1 shows how that boundary can shift over time using the shadow evaluation. H2 explains who manages it, compliance through the AOP. There are three main ideas, three types of execution, shadow evaluation to build trust, the AOP as a single source of truth, and a confidence gateway to enforce boundaries in the real time. Next week, I will bring these ideas together into what I call the governance backbone. 4 key mechanisms that every regulated workflow uses it. I will walk through the workers' compensation claim from start to finish, showing where each mechanism comes into play. Together, they answer every question a regulator might have. What happened? Who made each decision? And why? Subscribe to stay updated, and I will see you next week. You can find the article link in the description.